Our last calculation for our weak acid strong base titration asks us to go just past the equivalence point, 2 milliliters past to be precise, and figure out what the pH of the solution would be. So we need a couple of pieces of information as we come into this. One of them being the calculation that we did earlier that told us that we need 16.7 milliliters to get to the equivalence point. So since we're 2 milliliters after that point, we are at 18.7 milliliters of base. And we'll need this just a little bit later when we do total volume. For now, we can just put that in our pocket. Now what we've done is we've added enough moles of base to completely consume the moles of acid. And we've seen that moles twice now in two different calculations, and that's 2.5 times 10 to the minus 3. So up until this 16.7 milliliter point, these moles of base were being consumed and they're all used up. There's nothing that they can do to do anything to the pH. The only base that is present that can change the pH is this 2 milliliters of base. So I'm going to start by figuring out how many moles of OH minus ions there are in 2 milliliters of 0.15 molar NaOH. And so I'm just going to quickly take the volume and I'm going to multiply it by the molarity, and that's going to give me moles of base. And that's moles of base that are in excess. Whoops, I didn't put the E. So that's the moles of base that didn't react with acid. It's floating around in solution and it's changing the pH. Now I can't do anything to get to either pH, OH or pH with moles. I need a molarity value. So I need to remember that right now I've added 18.7 milliliters of base right now, and I started with 25 milliliters of acid to begin with. And that gives me 43.7 milliliters total that are floating around in that flask. So there are 3 times 10 to the minus 4 moles of base floating around in a total volume of 0.0437 liters. And I can quickly whip out a little concentration here. Probably more quickly than you because I did it on paper before I did this video. That concentration is the concentration of the NaOH, but it also turns out that it's the concentration of the OH minus. And if I take the negative log of said concentration, which is very tiny, I'm going to get a pOH of 5.16. And then if I subtract that pOH, I'll get a pH, and that pH happens to be 8.84. Now I'm past the equivalence point, but not too much further past the equivalence point. So my pH should be less than it was before. Sorry, more than it was before, because I'm adding something with a higher pH. So at the equivalence point, the pH was 8.26. Now 2 milliliters past the equivalence point, I am more basic, but only a little bit so. So this calculation seems like it's fair to me.